Hello everyone and welcome to my channel From Root to Best. Before starting today's topic, I just have a request to you. If you are new to this channel, please subscribe to this channel. Your subscription will help me a lot in creating new videos and uploading. And if you are not new, if you have all previously seen my videos and liked my work, please like my videos and share it with your friends. This will again be very helpful. And if you are having any doubt or if you want any specific topic that I must create a video on, do let me know in the comment section. I read all the comments. So without wasting any further time, let me quickly start today's topic. So today's topic is finding non-repeating integer. So what exactly does that mean? It means, let me just give you one example first. So let's say we have an array of integers. Within that array, all the numbers are repeated exactly twice except for one number. One number is non-repeated or has not been repeated in that array. So we just have to find that non-repeated number. All the other numbers are repeated exactly twice in that array. Okay, so this is the condition. So for example, let's say this is our array. Let me quickly give you an example. So this is our array 6, 8, 2, 3, then 8, 3, 2, 6 and 5. Okay. Now in this example you can clearly see that all the elements or all the numbers, for example 6 is repeated twice, 8 is repeated twice, 2 is also repeated twice and 3, but 5 is not repeated. So we have to find this non-repeated number from this array, and this number can be present at any position. I mean, in this example it's present at last position, but this number can be present at any position. Okay, so let me just change the position for your understanding. Okay, let's say, let me remove 5 from here and let me add it this position. Okay, and okay, so this is the number which we have to find. Now I hope this problem is clear to you. Now to solve this problem, right, solution is quite simple. From the first approach, what we can think of is we will simply repeat through all the numbers, all the elements of that array, and we will keep on counting the repetition or counting the appearance of that number every time. And for the number which has been repeated only once, we will simply return that element or number, right? So let me show you the approach first. Okay, so for example, the first solution that we can have, or the brute force solution that we can have first, is this, right? So what we will have, we will basically have a for loop that will run from 0 index of that array to that array. Let's say the array is error, or let me just define here. Let's say we have error. Okay, I'm not assigning any value. You just assume this example what I have shown there is the same present in the array. Okay, now here what we will have, we will have array dot length and I plus plus. We will repeat. Now to count the repeating number, we will have one more nested for loop. So let's say 0. This will also run up to the array length and plus plus, right? Finally, what we will do, we will simply check if the element in the first for loop is equals to the current element of the nested for loop, right? If it's equal, yeah, we will simply increase the count, right? Count plus plus. Okay, we can have a count variable defined inside for loop, right? Count initialized to 0, and after the inner for loop, if the count for that element not more than 1, then that's our non-repeated number. So we can have a check here if count is equals to 1. So here we can simply return array of I, right? And else if we don't find any non-repeating number, we will simply return -1. Okay. So just let me just zoom out a bit. Just have a look at this solution. This solution is quite simple. What we are doing here, we are simply iterating through all the elements in nested loops, and we are checking if that element is equals to any other element of that array. We are increasing the count, and for any element, if count is 1, we are returning that element as non-repeated. Now, what's the problem here? If you can see, we are using nested for loops, and both the for loops are running n times, correct? So the time complexity, this approach will automatically become order of n square. Now clearly you can see if we have a time complexity of order of n square, which is definitely not good, and especially when we are dealing with large numbers, right? So if the array size is huge, so for example, let's say we have a 1 million elements in that array, right? Or 1,000,001 elements. So out of that 1 millions are repeated and one is the non-repeated element. Then with this time complexity, the iteration we will have is 1 million square. So which is definitely it's not a good solution or good approach. Then what should be the better approach? One might think that instead of having nested for loop, we can have a single for loop. We will maintain a hash map where we will keep the frequency of each and every element. So where key will be that element and value of that hash map will be the frequency of that element. And then in a separate loop, we will check for which key the frequency is 1, right? That we can return. Let me just show you the next solution. Okay. So let me write it here. Okay. Better solution using hash map. So what is the better solution here? Okay. Let us have that better solution. So as I said, instead of nested for loop, we will have only one for loop, and in that, using that for loop, we will calculate the frequency of each element present in that array. Okay. So for example, first of all, we will have a map, right? Map of integer comma integer, where in first integer is the element of that array and second integer will be the frequency of that array or number of times it has been repeated, right? So let me name it frequency map. Okay, and it will be a hash map. Now what we will do, we will have a for loop which we will again run from 0 index to array length, right? Okay, and here what we will do, we will simply do map or frequency map in our case dot put. What we will put, we will put error dot I, and then again we will first take that value. Instead of get, we will use get or default. So by that way we don't have to write any additional code to first get, then add, if not present, add +1. So it will simply give me, if that element is present, it will give me that value, or default we can give as 0, and we will increment that number 1 frequency by 1. That's it. So we have already calculated the frequency of each element from that array. For your understanding, let me just define array here. I'm not initializing with any values, just assume the values will be same as we have shown in this example. Okay. Now, so once the frequency is calculated, we will again have one more for loop where we will get the numbers from the frequency map key set. And inside this for loop, we will simply check if frequency map dot get this number is equals to 1 or not. If 1, we will simply return this number, because this is the number which has frequency 1, that means it has been repeated only once, right? Otherwise we will continue, and if we don't find any number, any non-repeating number, we will simply return -1. Now, or in compared to the previous solution, this solution looks much better because the time complexity we have successfully been able to reduce it to order of n, because we have two for loops but they are separate for loops, and the maximum iteration any of the for loops can have is n, the number of elements of that array. So we can clearly say the time complexity for this approach is actually order of n. But here one more problem or one more point that we can observe here is the space complexity. Now since we are using an additional hash map, maximum size can be the number of elements itself. So the space complexity of this approach is also order of n, because we are creating a hash map whose maximum size can be of n, right? So that's why time complexity we have been able to reduce to order of n, but space complexity is increased here to order of n. Whereas in our previous approach, since we were not using any additional variable, so space complexity of this approach was order of 1. Space complexity for this approach was order of 1 because we were using constant space, correct? But time complexity was order of n square. And in this next solution, time complexity has been reduced to order of n, but space complexity has increased to order of n also. So what can we do to find a solution which is also having less complexity from the first solution, and also having less space complexity from the second solution? Okay. So what we can do here? Now let me tell you one interesting fact of a bitwise operation that we might have known, but we don't usually use it in our solution normally. Okay. So that bitwise operation is XOR operation. Now if you all have studied the binary operations carefully, you must have known about AND operations, OR operations, NOR, NOT, NAND, and XOR operations. Now, what XOR operation exactly does, right? XOR operation does is when we are doing XOR with, let's say, 0 XOR, this is the symbol of XOR, okay? 0 XOR 0, it will return us 0, okay? Then 0 XOR 1, it will again return us 1. 1 XOR 0, the result will be 1, and 1 XOR 1, the result will be 0. Now, this is what XOR operation is, correct? So, from the explanation, you can clearly see the result will be 0 when we are doing XOR of the same number, right? When we are doing XOR 0 0, the result is 0, or 1 1, result is 0. But the moment two digits are changed, 0 1 or 1 0, the result is 1 of the XOR operations. Can we use this property of XOR operation to find a better solution of our problem? Now, as I said, in our problem, all the elements of that array repeats exactly twice, except for one element. So, what will happen if we perform XOR operations on these numbers? XOR 6, 8, then XOR 2, XOR 3, XOR 8 again, 3, 5, 2, 6. Let me show you with an example here. Let me copy this array. So, this is our array, right? So, what is the binary representation of 6? So, 6 can be represent 110. That's the binary representation of 6. And what is the binary representation of 8? Okay, let me have 8 also here. 8 is 1000, correct? So let me just add a 0 in MSB to place all the bits in same place. Okay. Now if we perform XOR operations with 6 and 8, right? What will be the output? Right? Let me write XOR here. Output will be, so 0 XOR 0, let me write it from here. 0 1, when we do 0 XOR 1, it's 1. When we do 1 XOR 0, it's also 1. When we do 1 XOR 0, again 1, and 0 XOR 0, 0. So the XOR value, if we transform it into decimal, it will be 14. Now when we perform XOR, okay. Now if we do XOR again with this 14, so next element of this array is 2. 2 is what? 0 0 0, sorry, 1 0. Now if we perform XOR, what will be the result? So let us calculate again. So 1 XOR 0, 1, right? 1 XOR 0, 1, 1 1 0 0 0 0. This value is nothing but 12. Okay. Okay. Now comes to next number, that is 3. Okay. So let us perform XOR of 3 here also. So 3 is 0 0 1 1. Correct. Okay. Now comes here. I guess the XOR will be this, which is nothing but 15, right? Now next element of the array is 8 again. Okay. So let me write 8. Okay, let me just copy this. Yep. Then what it will have 0, 1, 1, 1, right? This value is equals to 7. Okay, so next element 3 we have done. Now what is the next element? 3 again, right? 3, 5, 2, 6. Here let us have 3 again. But it will have 0, 1, 0, 0, right? Which is equals to 4. Now 3, 5, right? 5. 5 is 0, 1, 0, 1, which will result us in 0, 0, 0, 1, which is nothing but 1. Next is 2 and 6. So 2 will be 0, 0, 1, 0, which is equals to 0, 0, 1, 1, which is nothing but 3. And then last digit, that is 6. Okay, so 6 is 0, 1, 1, 0, correct? So what will be the result? 0, 1, 0, 1, which is nothing but 5. Now let me zoom out. After performing XOR operations for all the numbers, what is the result we are getting? 5, which is the non-repeating element present in the array. How it's happening? Even though we are performing XOR operations on different element, but at the end, all the repeated numbers, when we are performing XOR within them, so what XOR does, when the numbers are same, it results in 0, right? So no matter what value, when we are performing XOR in the repeating numbers, they are actually resulting in 0. So all the repeating numbers are actually cancelling each out except for the non-repeating number, because when we are performing XOR with between 0 and the non-repeating number, the result is the non-repeating number. And that's why after performing XOR with all the elements we have, we are getting 5 or the non-repeating number from that array as our result. Now, with this approach, what we will have to do? We will simply have to iterate through all the elements of that array once, only once. So the time complexity will automatically becomes order of n, correct? And since we are not using any additional variable, I mean, we will have a result, but that will be only one integer, right? Apart from that, we are not using any additional variable whose size depends on the size of the array, right? So that's why the space complexity of this approach will also become order of 1. Now, out of all these three solutions, as you can see, first solution had time complexity order of n square, space complexity order of 1. So space complexity was good, but time complexity, it was very bad. The second solution, time complexity was order of n, better, but space complexity was increased to order of n. But with this final optimized solution, Finally, we are getting time complexity as order of n, similar to the second solution, and space complexity as order of 1, similar to the first solution. So clearly we can say that this approach is the best approach among all these three approaches, right? So if the theory or the explanation is clear to you, now let us move to code. Okay, so just give me a second. I will open my IDE and join back. So this is my class non-repeating number, where I will write the solution with the best approach. Okay, so let me quickly create the function. It will return me the non-repeating number. So int, then find unique number. It will accept an integer array. Okay, we will basically go, or let me have a result variable first, then for int I equals to 0, I less than array dot length, and I plus plus. What we will do, we will simply perform XOR operations, right? XOR operations with what? Array of I, right? And at the end of the for loop, we will simply return the result. That's it. So this a simple for loop with XOR operations for all the elements, and we will get the result. Now let me quickly write the main method and call this find unique number method from there. Okay, public static void main. So let me first initialize an array with integer array with the same numbers we had, right? So 6, 8, 2, 3, 8, 3, 5, 2, 6. Okay, I guess this was our array. 6 has repeated 2 times, 8 has repeated 2 times, 2 has also repeated 2 times, 3 has repeated 2 times. Only 5 is the non-repeated number, right? So let me system.out.println non-repeating number. Okay, so I hope I don't have to explain this code because this code is quite simple and self-explanatory. Let me just run this program. Non-repeating number is 5, right? And this XOR is actually holds true for all the numbers. So for example, if I let's say add few more numbers, 10, 34, 56, then 56 again, 10, 34, and let's say our non-repeating number is 11. Okay, now if I run it again, you can see we are getting 11. So this solution actually doesn't depends on the numbers of that array and size of the array. The only condition is all the elements has to be repeated only twice, because the moment it will repeat more than twice, this solution will break. We should have one non-repeating number, in this case 11. If we don't have any, it will result in 0, because all the elements will cancel each out through this XOR operations and result in 0. So let me just show you that also. See, because we don't have any non-repeating number. Okay, we can add a check here that if result is 0, return -1, and all those things, all those cosmetic changes you can do, but the solution will remain same, and this is the best solution, best approach to solve this problem. So I hope this video helps you to understand the problem and how we go from brute force approach to best approach or best solution, right? So if this video really helped you, please like the video and share it with your friends. And if you are new to my channel, if you are not visiting first time but you haven't subscribed to my channel, please subscribe to this channel, because your subscription will help me in growing my channel and it will motivate me in creating more such interesting videos for you. And if you have any doubt, not just with this video or any of my previous videos or short videos, do let me know in the comment. I will explain you there. Or if you want me to make any video on any specific topic, that also let me know in the comment. I will create that explanation video for that topic. Okay, so thanks for now. We will meet again in my next video.